Lesson Plan Project by Emily Reese. The first week of the unit, students participated in a gizmo activity that allowed students to explore stream processes and develop an understanding of landscape evolution over time. Students also completed a self-paced Nearpod lesson, which reviewed erosion and deposition and introduced students to a stream table experiment. Lastly, students worked through a Desmos module on stream processes and how stream channels change over time. Student work was embedded in the Desmos guided note presentation, and they were involved in interpreting and summarizing and analyzing stream process phenomena in a partner. The second week of the unit, students explored processes of weathering, erosion, and deposition of materials and how those processes change the surface of the earth. In math class, students created bricks using different ratios of materials and explored how each brick responded to erosion and pressure. Students used unit costs to determine the overall cost of each brick. Students followed a Google slide presentation to help guide them this week. And at the end of the week, students tested their designs and reflected on the entire learning unit by choosing a technology platform to demonstrate mastery of content. Students should have already been able to explain the concept of a unit rate associated with a ratio, as well as solve unit rate problems. Students also should have had background knowledge in weathering, erosion, and deposition from third grade. In order for this lesson to be successful, the students' prior learning knowledge needed to be assessed from third grade and fifth grade. Before implementing the unit, students were engaged in a Blicket warm-up that assessed their comprehension of ratios and percentages. The warm-up was used to gauge if the students needed a deeper review of the math concepts prior to implementing the unit. The teacher administered a Google Form pre-assessment probe to activate students' prior knowledge about how moving water can change the surface of the earth. The results of this probe was used to guide instruction to address misconceptions and gaps in understanding later in the unit. The students explored how landforms are developed by processes of stream erosion. The gizmo allowed students to explore stream processes and develop an understanding of landscape evolution over time. Students worked through the exploration guide to learn about river erosion and landscape development. Students manipulated the landscape to learn how erosion changes land features over time. The last question on the exploration guide revisited the scenario presented in the formative assessment, and students had the opportunity to reassess their initial answer. The students also completed a self-paced Nearpod lesson, which reviewed erosion and deposition. In this Nearpod, they watched two separate videos describing stream processes and landform evolution, and then reviewed the content with a time to climb review game. Students also worked on a Desmos module on stream processes and how stream channels change over time. In this Desmos, students had to drag and drop, have discussion, and write short responses to complete the tasks. Students also utilized Google Slides to use ratios to build bricks from sand and glue. They predicted how changing the ratio of the ingredients in a brick could impact its strength. Students worked in small groups to create a set of 6 bricks. There were 3 different mixtures for students to create bricks from, and students tested their bricks after they were dry. Students utilized Google Slides to observe how well their brick held the weight and the effect of water, and recorded all observations on the Google Slides student observation sheet. Students also worked through the ratios and percentage tasks to calculate the cost to build bricks. This assignment was housed in their STEM Google Classroom. Finally, students had choice in their overall reflection of the unit. Students were able to use Flip, Canva, or Google Slides. The teachers utilized differentiated rubrics to grade students on their reflections and presentations based on the formative assessment at the beginning of the unit. The strengths of the weakness were that the unit was a hit with the students. Each pair of students took ownership of their work and were proud of what they produced. They liked that each day had a brief learning activity, which then led into the overall project reflection. The students liked each of the technology platforms included in the unit, And many students reflected on the gizmo activity as it had changeable variables to the activity that they could manipulate. The weaknesses were that many students expressed that they would have liked more time to complete the reflection portion, as that was only one day. The students felt very rushed in their responses. The students did just what I did. I wish I had given them multiple examples for their final presentations because I would have received more varying types of final project reflections. Reflection. If I had more time to complete this unit, I would add one more week to the unit to include the community connection aspect of STEM. I would like for students to consider the Yellow River and the erosion, weathering, and deposition that is happening there. Since the Yellow River is in Gwinnett County, students could explore local flooding and then write a proposal or plan to prevent flooding on the Yellow River. Students would share their proposals or plan with a peer, and then recommended proposals could be sent to city officials to review. This unit was one of my favorites I have ever taught. I was actually really excited that my principal allowed me to collaborate with Miss Tiara. The students loved this unit as they worked so hard and they were engaged the whole time. It has definitely made me think about how I approach lessons that allow for project-based learning and personalized learning. The more that I reflect on this lesson, the more I can think of things that I could do to improve my teaching, coaching, and increase student engagement.